Hello, it is the Math Train, and we're going to be doing velocity and acceleration applications. We're going to include therefore statements for every question, and we're going to be working with the position function, which is s of t. We're going to be working with the velocity function, which is v of t, and we're going to be working with the acceleration function, which is a of t. And we're going to be doing word problems. That's what application means. Applications means word problems. So word problems are commonly used to test one's knowledge of velocity and acceleration with derivatives and comprehension of applications. So read the questions carefully and I'll tell you how to solve them. To dramatically advertise the effectiveness of a new football helmet, a melon is taped inside of it. The helmet is dropped from a tower of 78.4 meters high. The height of the helmet is h in meters after t seconds is given by h of t equals 78.4 minus 4.9 t to the power of 2 until it hits the ground. So h of t is the height, and the input for t is time. So h of t is how far away it is from the ground, and then t is how many seconds has passed, and that's our function right there. So t is the input of time, and h of t is the output of distance. And then we have a little picture right there. So it's a 78.4 meters tall building. There's a watermelon and helmet, and everything else, right? So you can go ahead and draw that diagram, and I'll give you a moment for you to pause the video and to write everything down. All right, moving on. So this one is in green. We have find the velocity of the helmet after 1 and 2 seconds. Find the velocity. Find v of t by taking the derivative of s of t, otherwise known as h of t. Q the position function, Q the derivative of the position function, Q the velocity function, Q inputting 1 and 2 into the velocity function, Q the answer to what the velocity of the helmet is at 1 and 2 seconds, and then we input 1 and 2 seconds into the velocity function, and aka the derivative of h of t, and then we find the velocity of the helmet after 1 and 2 seconds. Back to our handy dandy pencil. So s of t is equals 78.4 minus 4.9 t to the power of 2. So what we find here is the derivative of h of t, aka the velocity function. So the constant rule, if there's no variable attached to a term in the equation, then it just equals 0. And then we use the power rule to find the velocity of this part right here. And our answer is negative 9.8 t. So that's the velocity. And then what we do is we take v of 1 and v of 2. So negative 9.81 equals negative 9.8. And remember that we always measure velocity in meters over seconds. And then we take v of 2, so it's negative 9.8 in brackets of 2. And that equals negative 9.6 meters per second. Hold on here, I'm just going to find my calculator quickly. Found it. My calculator is green. And then we do a therefore statement. V of 1 equals negative 9.8 meters per second, and v of 2 equals negative 19.6 meters per second. So the velocity at 1 second is 9.8 meters per second, and the velocity at 2 seconds is negative 19.6 meters per second. Then we do a big old circle around our therefore statement. Moving on. Actually, I'll give you a minute to write that down. Okay, let's move on. This one is blue. When will the helmet hit the ground? So t equals what? So what time does the helmet hit the ground? When h of t equals 0. So the height is 0 meters. That's why h of t equals 0. And what does t equal? So the values of t. What time does it hit the ground? And solve for t. So what we do is we factor the equation to find the values of t, and we can do this throughout multiple ways. Back to our handy dandy pencil. So what we did was we moved that 78.4 to the other side, and when we switch it over to, and it passes the operational sign, or the equal sign I meant, it becomes negative. And then we get rid of this negative 4.9 by dividing that by both sides. And then we are left with t to the power of 2. And then negative 78.4 divided by negative 4.9. Just jam those numbers into your calculator there. Is 16. And then plus or minus the square root of t squared, because we want to get rid of the square, or the to the power of 2, and we do that by taking the square root, and that's plus or minus the square root of 16. So we got rid of we want to get rid of this, so we plus or minus the square root of 16 is plus or minus 4. And then we have plus or minus 4, which means t equals 4 seconds or negative 4 seconds. So negative 4 seconds is not possible with time. So we're going to take our handy dandy blue pencil there. We're going to X that out, and we'll make a little note above here. Not possible with time. And we'll do a big old arrow to negative 4 seconds. And then we have our answer here. And we'll circle it. And we'll do a big old therefore statement. The helmet hits the ground at 4 seconds, or t equals 4 seconds. Okay, so the helmet will hit the ground at 4 seconds, t equals 4 seconds. So that's how we solved for t. We moved the 78, let's take out our lightsaber tool, we moved 78.4 to the other side, it became negative 78.4. And then we got rid of the negative 4.9 by dividing, because it was multiplied by t, so we divided it out on either side. And then with this answer, negative 78.4 minus 4.9, we got 16. And then these canceled out, so we got t of 2 equals 16. So we used the square root, and we square rooted both sides to get rid of the t to the power of 2. And when we square root, we always do a plus or minus in front. And then we got t equals plus or minus 4. And that t equals 4 seconds or negative 4 seconds. And again, it was not possible with time to be negative 4 seconds. So the helmet hits the ground. The helmet will hit the ground at 4 seconds. T equals 4 seconds. and that's our answer. So the manufacturer's demonstration will be effective if the melon is undamaged after impact. And we say impact is when it hits the ground. The melon will remain intact if the impact speed is less than 30 meters per second. Is the demonstration effective? So meters per second is how we measure, is the measure of velocity. So we take the time, t equals what at impact, answers from part B, and we input it into v of t when t equals 4 seconds at impact. So we take the answers from B. When will the helmet hit the ground? We take the answer from B because that is when the helmet has impact, or when the helmet hits the ground. And we take t equals 4. T equals 4 seconds, and we input it into v of t. And then that'll give us the velocity. And if the velocity is less than 30 meters per second, then the demonstration is effective. If it is more than 30 meters per second, it is not effective. I'll give you a moment to write down the question. Okay, so what are we going to do here is the velocity is less than 30 meters per second at impact after t equals 4. So is velocity less than 30 meters per second at impact at t equals 4. V, the velocity, is negative 9.8 t. And then, so velocity is negative because it is going down. So our answer is probably going to be negative because we're going to input 4. Hold on here. we are going to input 4 seconds. We're going to input 4 seconds into velocity function. 4 seconds, if we go back to this question, is when it's the when of the impact. It is when the helmet hits the ground. That's what we found in this question. So we input the time of impact into the velocity function. So we input the time of, we input 4 seconds into the velocity function, the time of the impact into the velocity function, and then we will get the velocity of when it hits the ground. So there's our answer there, and we'll circle it. The reason why there's a negative symbol there is because it is going down. So the velocity is negative because the helmet is going down. So we have the velocity there, and the velocity is more than 30 meters per second. It is negative 39.2 meters per second. So, we'll do a therefore statement saying that the demonstration was not effective because the velocity at impact was 39.2 meters per second, and it was higher than 30 meters per second. So don't be confused. The reason why it is negative 39.2 meters per second is because it is going down. So let's say if it was negative 29 meters per second, then the demonstration would be effective. So if you need clarification on that, please comment or let me know. Alrighty. So the position function of a cheetah moving across level ground in a straight line, chasing after its prey. So let me correct that typo there. Is given by the equation S of t equals t to the power of 3 minus 15 t to the power of 2 plus 63t, and the velocity of that using the power rule is 3 of t to the power of 2 minus 30t plus 63. So what we did here was we dropped the t. We used that 2. We brought it down to the front. Multiplied it by its coefficient, meaning it becomes 30t. And then we did 2 minus 1, which would equal minus 30t. And then we brought that 3 down, and it became a coefficient. And it became 3 of t, and then we did 3 minus 1, which equals 3t to the power of 2. So that's using the power rule to get the velocity function. And I know I gave you the velocity function. We're going to go through how to solve each question, and then we will do the questions together. So where t is measured in seconds and s is in meters, so what is the cheetah's velocity after 1 second, 4 seconds, and 8 seconds? The velocity at 1 second, 4 seconds, and 8 seconds. Find the derivative of the position function. Find the derivative of the position function. So we find the derivative by using our various rules, like the power rule, the product rule, the quotient rule. Most commonly, the power rule. Then we input 1, 4, and 8 into v of t, and then we input 1, 4, and 8 into the variables in the equation, in this equation here. My apologies. Lightsaber tool in this equation here. We'll input 1, 4, and 8 into these variables right here. So that's how you solve A. So when is the cheetah momentarily stopped? So v of t equals 0, and then solve for t. Put the equation, let it equal 0, and then isolate t. In this case, we factor. Yeah, in this case, we factor. So what are the positions of the cheetah in part B? Take the answers from B and input it into the position function. S of t equals the answer, and take answers from part B. So we take when is the cheetah momentarily stopped. We take those times, and what are the positions of the cheetah in part B. So we take the answers from part B and we input it into the position function. So we'll get 2 answers because we're going to factor, and then we'll input those answers into S of t, and then we'll get the answer of the position of where the cheetah is at those times. So when is the cheetah moving in a positive direction, and when is it moving in a negative direction? So we draw a diagram with the information in part B and part C. We have when is the cheetah momentarily stopped, and when is and where is the cheetah momentarily stopped as well. So we draw a diagram of when the cheetah is momentarily stopped and where it's momentarily stopped. And we'll get more information with the other questions that we get, and then we'll add that to our diagram. And for this one, we're going to be doing a diagram as well. So find the position of the cheetah after 10 seconds and put 10 seconds into the position function S of t. So S of 10 equals what? And input 10 into t, the variable. And then we have F, so it's find the total distance traveled by the cheetah during the first 10 seconds. Add up the distances traveled by the cheetah from each point on the chart. Calculate the distance from each point. During the question, I will show you how to get the distant values between the points. So I'll show you how to get this value using this measure of distance. I'll show you how to get this value, and I'll show you how to get this value. The distances must be calculated and added, and I have that all in my booklet here. So 1 plus 2 plus 3, so first stride, second stride, third stride. We add those up, and that's the total distance traveled by the cheetah. Moving on. Compare the results in E and F. The results of E is where the cheetah is, or the position of the cheetah after 10 seconds have passed. The results of F is the total distance of the cheetah ran in the entirety of the 10 seconds. So, the results of F is the total distance of the cheetah ran in the entirety of the 10 seconds. So that's the total distance a cheetah ran in the entirety of the 10 seconds. And then E is where the cheetah is after 10 seconds. So we're going to be doing multiple diagrams. In order to compare the results, you will need written explanations, well-drawn diagrams, and calculations with conclusions as to the differences between the results. And a reminder, you will need therefore statements for every question that we have. So, what is the cheetah's velocity after 1 second, 4 seconds, and 8 seconds? So, we're going to find the velocity using the power rule. Okay. So V of t, we move the 3 down, and then we do 3 minus 1, which is 2. We move the 2 down, multiply it by 15, which is 30t, and then we do 2 minus 1, which is 1, so we don't need an exponent there to indicate 1. And then with, we have an exponent of 1, so we'll multiply that by 63, and then we do 1 minus 1, which is 0, so it's t to the power of 0, so we get rid of t, and so it's just plus 63. So that's how you get the velocity function, finding the derivative of the position function. So what is the cheetah's velocity after 1, 4, and 8 seconds? So 3, 1, 2. Just jam those numbers into your calculator there. So 3 in brackets 1 to the power of 2 minus 30 in brackets 1 plus 63. And that's 36 meters per second. Remember, we measure velocity in meters per second, and then for acceleration we do meters squared over seconds. Wait a second here. My apologies if you go back to the acceleration. Actually, no. It's velocity. Never mind. Okay, so we have v of 1, and then we have v of 4, and we have v of 8. So we jam these numbers into our calculator there. What you can do is we can, instead of inputting it again, you can go up into your calculator and you can change the 1 into a 4. It takes less time. And then we do v of 8. And then we have 3 of 8 to the power of 2 minus 38 in brackets plus 63. And for that one, the velocity is 15 meters per second. So we have different velocities, right? Of the cheetah's velocity after 1 seconds, 4 seconds, and 8 seconds. So the cheetah is running at different speeds at these seconds. So v of 1 equals 36 meters per second. V of 4 equals negative 9 meters per second. And you can see at v of 4, the cheetah is most likely moving in a negative direction because the velocity is negative. And v of 8 is 15 meters per second as well. So the velocity at 1 second is 36 meters per second. The velocity at 4 seconds, the velocity of the cheetah at 4 seconds is negative 9 meters per second. And the velocity at 8 seconds is 15 meters per second. And we'll do a big old circle around our answer. We can do a better circle than that. When is the cheetah momentarily stopped? So v of t equals 0. That means the velocity equals 0 meters per second when it is stopped. And we're solving for t. So what time is the cheetah momentarily stopped? And in this case, we're going to factor. Factoring's easy. We're going to take out this 3 because it is a common factor of 30 and 63. And then we're going to factor in what's inside the brackets. So t equals 7 seconds and t equals 3 seconds. Or t equals 7 and t equals 3. The cheetah is momentarily stopped at 3 seconds and 7 seconds. And we'll do a little diagram. So this is the cheetah stride. And you can see it stopped at 3 seconds and 7 seconds. So what is the position of the cheetah when he is resting? So we found the times it is momentarily stopped. Now we want where. So we want the location of this point and this point. Little question marks. So where is the cheetah momentarily stopped? That's what we're looking for. We have t equals 3 seconds and t equals 7 seconds. So input answers from B into the position function to find the positions of the cheetah at the points of rest. So we have S of t equals t3 minus 15t2 plus 63t. Let me take another sip of my coffee. And then our answers from part B was t equals 3 seconds and t equals 7 seconds. So what we're going to do is we are going to input these numbers into the position function. So S of 3 is 81 meters. So this right here, 81 meters, so that's t equals 3 seconds, and the distance attached to that is 81 meters. And then we have S of 7, so 7 to the power of 3, 15, 63, 7. So we inputted 3 and 7 into the position function, into those variables, all of these variables, 3 and 7, into here, here, and here. So t equals 3 and t equals 7. And we input those numbers into the variable. And then when we input 3 and 7, those times, we get an output of distance. So we jam these numbers into our calculator here. Seven to the power of 3 minus 15 brackets 7 to the power of 2 plus 63, 7, 49 meters, and we'll circle it. So, at 3 seconds, the distance of the position of the cheetah is 81 meters, and at 7 seconds, the distance and the position of the cheetah is at 49 meters. And then we'll do another diagram. So we have this distance and this distance. T equals 3, T equals 7. And you can add seconds on there, but you don't have to. And then we have this distance at T equals 3 seconds. And then we have that distance at T equals 7 seconds. So this one is 81 meters, and this one is 49 meters. So, and then again, this is the cheetah's stride. So we added to the diagram with the parts from B and the parts from C. So now we have this information and we put it into a diagram of the cheetah's stride. So, when is the cheetah moving in a positive direction and when is it moving in a negative direction? So we're going to do a diagram and we're going to explain. So this is the cheetah's starting point, and we'll label that A, B, C, and then D as well. And then we'll get our handy dandy highlighters. I'm thinking about using pink and blue. Positive direction. Negative direction. So we have T equals 3 seconds. T equals 7 seconds. We have the first stride. We have the second stride. And we have the third stride. Oh boy. We have 49 meters. clever. Oh, sorry. So, we forgot to do a therefore statement for this question. Circle the therefore statement. Circled. And we'll do we'll put it right here. The position of cheetah at 3 seconds is 81 meters. And then we have the position of cheetah at 7 seconds is 49 meters. So that's our therefore statement, and we have cheetah stride, and then we'll do an in brackets diagram with the information that we have. When is the cheetah moving in a positive direction, and when is the cheetah moving in a negative direction? We're going to take our handy dandy calculator again, and we're going to ink out a box. The pink is the positive direction, and the blue is the negative direction. So, we can also put it like this. The first and third stride is the cheetah moving in a positive direction. And the second stride is the cheetah moving in a negative direction. And then we can do it like this. We can do the times. So if the time is less than 3 seconds, and if the time is greater, let me start over, please. If the time is less than 3 seconds, and if the time is greater than 7 seconds, then the cheetah is moving in a positive direction. And we have T in the middle here, between 3 seconds and 7 seconds, then it is moving in a negative direction. So t is greater than 3 seconds, and t is less than 7 seconds. And then the cheetah is moving in a negative direction. Moving on. Right here is a clue to what we're doing next. And all of this is their first statement. Little box. The cheetah's stride. So find the position of the cheetah after 10 seconds. Input 10 seconds into the position function. So we have another time, and we're going to find another position of the cheetah, or where the cheetah is after 10 seconds. So we have the position function. So we have s of 10, and we'll input 10 into the variables. The variable of t. So we're going to jam those numbers into our calculator here. to the power of 3 minus 15, 10 to the power of 2. And the position of the cheetah after 10 seconds, or at 10 seconds, is is 130 meters. So we'll do another diagram, and we'll do a therefore statement. The cheetah's position is 130 meters at 10 seconds. And we'll copy this diagram we're going to copy, and then we're going to paste. So we have t equals 10 seconds. And then we have 130 meters. And then we have t equals 3 seconds, t equals 7 seconds, t equals 10 seconds. And then we have point A, B, and C, and D. And we have B is 81 meters, and then is at the distance of 81 meters. And then we have the time as well, and then point C, the position of the cheetah is at 49 meters, and then at 10 seconds, point D, the position of the cheetah is at 130 meters. So there is that there. Okay, so we have an almost complete diagram. We've labeled our points. We have the times, and then this one is t equals 0 seconds. So that's point A, point B, point C, and point D. So we have first stride, second stride, and third stride as well. And then we have everything here. So we'll circle our therefore statement. What is the total distance traveled by the cheetah during the first 10 seconds? I'm just gonna get my charger out here because I don't want my iPad to die. So, what is the total distance traveled by the cheetah during the first 10 seconds? So, I'm going to repaste this diagram. So we'll go back to our cutaway tool, we'll paste and match the style, and then we'll add the differences in what we did. 130 meters, t equals 10 seconds, t equals 0 seconds, and we'll underline all of those, A, B, C, D. So the total distance, so we need to calculate the first stride, and the second stride, and the third stride. So, so we have 81 meters, and that's the first stride, because distance from A to B is 81 meters at point B. That's the distance from the starting point to B is 81 meters, so that's the first stride. Quite an easy one, I would say. Now to get the second stride, what we really need to do is we need to subtract 49 meters from 81 meters. So we, let me get my lightsaber tool, we subtract this distance from here, from the total distance, and then we are left with what we have in there. So it would be 81 meters minus 49 meters. So that's the position of B, or the second point. And then we have position of C, the third point. So we're gonna subtract this distance and we have that number, it's 49 meters from the entirety of the 81 meters, and then we will be left with what is left here, and that would be our result, would be that distance right there, and that'll be the length of the second stride, and then we will add that to our calculations. So 81 minus 49 is 32 meters, and that's the length or distance of second stride. So, and now we're off to calculating the third stride. So, the third stride. So we have the position of the fourth point, which is D, and then we have the position of the third point, which is C. So what we do is, to calculate this distance, we are going to subtract this from the entirety of the 130 meters, and then we will be left with the third stride. So, subtract 49 from the entirety of 130 meters, and then we'll be left with the result. So we have 130 meters, and we are subtracting 49 meters. So we have the position of D, that's the fourth point, and then we have the position of C, that's the third point, with 130 minus 49 equals 81 meters. Well, would you look at that? just because the first stride was 81 meters and the third stride is 81 meters. So, and that's the length and distance of the third stride. So, we have 194 meters. If we add up 81, 32, and 81, stop talking. And that's going to be 194 meters. And that's the total distance that the cheetah traveled during the first 10 seconds. And we'll write that the total distance that the cheetah traveled is 194 meters. Okay, so for E, F is the total distance traveled by the cheetah, and G is compare the results. In parts E and F. So the results of E is where the cheetah is after 10 seconds. The results of F is the total distance the cheetah ran. So we're gonna do an explanation. I'll bring you back to what we wrote. The results of E is where the cheetah is, or the position of the cheetah after 10 seconds have passed. The results of F is the total distance the cheetah ran in the entirety of the 10 seconds. In order to compare, you will need written explanations, well-drawn diagrams, and calculations with conclusions as to the differences between the results. So we are going to start that. And then we'll go to our handy dandy back to our question, and then I have it written out in my booklet here. So E is where the cheetah is after 10 seconds. F is the total distance traveled by the cheetah. So, for E, we input t equals 10 seconds into the position function measured in meters. And the position function is s of t equals t to the power of 3 minus 15t2 plus 63t. And that's to find where the cheetah is after 10 seconds, or at 10 seconds. We'll do a little at symbol and put those in brackets there. Sorry. So S of 10, we're going to input 10 into the variable of t. So S of 10 is 130 meters. So, and then that answer right there is the position of the cheetah at t equals 10 seconds. It is not the total distance traveled by the cheetah in the entirety of the 10 seconds. That's what F is. It is where the cheetah is at 10 seconds. And that's the difference between them, is that this is the total distance traveled by the cheetah, and if we look at the diagram, we calculated that using all of these calculations. So that's the total distance traveled by the cheetah, and we can use our lightsaber tool and say we calculated each stride. And what we found there was is where the cheetah is at 10 seconds. So that's what we found in E. I believe it was E. Yeah, that's what we found in E. And in F, it's the total distance traveled by the cheetah during the first 10 seconds. So those are our calculations. And then we have F. And we this might be quite small because I'll have to write small in order to. We have 81 meters minus 49 meters, and that's 32 meters, and that's the position at 3 seconds, B, and that's the position at 7 seconds. And that's the second stride distance between B and C. And then we have 130 meters. We have a position, that's the position at 10 seconds, position at 7 seconds, that's 81 meters, third stride, distance, between C and D, and then we just have the first stride, which is 81 meters. That one we got easily, because if we go back to the diagram, we have points from A to B, and that's 81 meters. Use from A to B, it's 81 meters. So that's how we got first stride. Quite easy. And that's 194 meters. And that's the total distance traveled by the cheetah. And now it's time for us to do diagram. And we'll do one for E and one for F. So E is where the cheetah is after 10 seconds, and F is the total distance traveled by the cheetah. So we'll do mini diagrams to compare the two. So, again, E is where the cheetah is after 10 seconds, so T equals 10 seconds, and that's 130 meters. And then we have the total distance traveled by the cheetah. So we have first stride, second stride, and third stride. Let's redo that one. Take another sip of my coffee. So we have first stride, second stride, and third stride. So with that one, I wish there was more that we can add to E. So where is the cheetah after 10 seconds? So maybe we'll add the position and we'll circle what is important. So this is t equals 3 seconds, t equals 7 seconds, and then we have the distances at t equals 3 seconds, 2, and t equals 7 seconds, and we have the distance for that. And then we have so those are the differences between E and F. And as a reminder, we'll do the position at 10 seconds, and then we will do distance traveled. In the entirety of the 10 seconds. So we'll do where the cheetah is at 10 seconds. And then we'll do the distance traveled by the cheetah. So there are different diagrams. So there are diagram differences. And then we have calculation differences. With worded explanations. And then our last step is our conclusion. And go back to so, in order to compare, you will need written explanations, well-drawn diagrams, and calculations with conclusions as to the differences between the results. So we'll start that. We have the calculation with conclusions, we have the well-drawn diagrams, and then we have the written explanations. So our written explanations will be our therefore statement, just referring back to the how-to. So we're on the final step. So in conclusion, the results of E is where the cheetah lays upon the graph at 10 seconds. So t equals 10. And we'll input into the function. Then S of t is 130 meters. And we'll input time and output distance. The results of F is the total distance traveled by the cheetah. From first stride to second stride and to third stride. It is the distance from point A to point B . from point B to point C. And from point C to point D. The calculations differ. The calculations differ. In part E, you are inputting t equals 10 seconds into a function. You are inputting t equals 10 seconds, into a function, aka the position function. And are receiving an output of 130 meters of distance. In part F, you are calculating the distance length between all points and labeled on this graph. The distance length, total distance traveled by the cheetah, you are calculating the total distance, the distance length, the total distance traveled by the cheetah, and adding all stride lengths. While also calculating stride 1, 2, and 3. So, should we review anything? in conclusion, the results of E is where the cheetah lays upon the graph at 10 seconds, t equals 10 seconds, and we input that into the function, the position function. Then S of t equals 130 meters. So our answer is 130 meters. And so the cheetah lays upon the graph at 130 meters at 10 seconds. We input time, and we have output distance. The results of F is the total distance traveled by the cheetah from the first stride to second stride and to third stride. It is the distance from point A to point B, from point B to point C, and point C to point D. The calculations do differ. In part E, you are inputting t equals 10 seconds into the function, aka the position function, and are receiving an output of 130 meters of distance. In part F, you are calculating the distance length, total distance traveled by the cheetah, and adding stride lengths, while also calculating stride 1, 2, and 3. So in these ways, part E and F are different. And I wanted to see if we can improve our graphs here. So this is graph A, graph 1, and graph 2. So, I hope you found this helpful. I hope this was a good video for you to watch and listen to. And if you have any questions, please ask. And thank you for watching.